So what you guys did in the break? Yes. Good evening, sir. Good evening. Guys, tell me, every day you have classes of the same subject twice. Like today you have two chemistry classes, right? Maybe tomorrow you have two physics classes. So what do you do in the break? Like here in India it's now 9:20. So I have to take the dinner. So I rushed down and take my dinner and come back. What about you? You also eat food. Okay. So just like me, you also had food. Nothing. Acha, हाँ, just time pass waiting for the next class to start. Acha. क्यों Abdul? Why you want me to finish this class quickly? My dinner will come later. Okay, so your dinner will come later. Where are you right now? Acha, dinner will come soon. Dinner will come soon means acha in India. Okay, so is your dinner coming from FMB? Is it something like that? Good evening, sir. Hi, good evening. Okay, chalo, ठीक है. I will try. Look, the things that I have to cover today, I have to do it today only. क्योंकि क्या है कि if I just don't complete that thing today, we have to take that in the next lecture. And you know this chapter is one of the lengthiest chapter we have. And even in your class 11th, your every chapter that we have is lengthy one. There is no chapter, which is not so lengthy. Every chapter is lengthy. Only redox reaction is the chapter which we can finish in like 3 or 4 lectures. Rest every chapter require more than 10 lectures. So chalo, we will continue our topic. And guys, now we will first talk about resonance, then polarity of the bond, and then Pajan's rule. These three topics we have to cover today. Once we are done with these three topics, then we will be able to start with the first theory, that is VSEPR theory. Chalo, before moving further, let's solve this question. The correct sequence of the bond length in single, double and triple bond, guys, what will be the answer? What will be the correct bond length? Option B is correct. Yes, that's the correct answer. Option B is the correct answer, because the correct bond length will be the single, then double and then triple. Triple is having the shortest bond length. Chalo, let's see the another thing that we have to start is the resonating structure. Now guys, first try to understand what is resonance. And before moving further, anyone from this class who wants me or who wants to explain, who wants to explain resonance? Anyone who wants to explain resonance? Okay, chalo, tell me, let's talk some funny thing. Let's take a funny example. I hope you take it as a funny example, because I take always funny examples, and maybe something which is quite relatable, but maybe some of you may get offended, but maybe some of you not. So how many of you have a crush on someone in your school? Maybe some of you have, some of you don't, or maybe something like that. But most of we, when we were in school, we have crush on someone. Like maybe you have crush on your classmate, or maybe your senior, or maybe your junior, something like that. So let's imagine you have a crush on someone. So what is the probability that that crush will come back to you and say I love you? Oh, Avan, that's so sad. Zero. Poojan is saying 0% chance. Which means, let's say if you like someone and she is very pretty, she is a topper, she is very rich, and you are like Jitra kind of boy, and you like her, but you are waiting for her to come to, I mean, you are waiting for her that she will comes to you and say, I love you, please be my Valentine, these are the dark chocolates for you, one bouquet for you, and let's go out on a dinner and let's have a candlelight dinner. What is the chances? Poojan is saying 0%. What about the other students? What do you feel, guys? What are the chances? Minus 1%. Can I say it only happens in our imagination? It's an imaginary thing. It never takes place in reality. It's something which we talk, it's something which we say, it's something which we think, it's something which we want. But in reality, it is not. In reality, it will never happen. Everybody agreed on this point? It's in our dreams. Yes. Same thing is your resonance. Resonance is something which we study. Resonance is something which we apply. Resonance is something which is very important in chemistry. Resonance is something without which we won't be able to study chemistry, organic chemistry, its mechanism. But you know, in reality, resonance is nothing. It's a hypothetical concept. We have thought about it. We were thinking about it. It reality, it do not exist. Are you getting this point? So now we are studying about resonance. Resonance, which is a hypothetical concept. Resonance is a completely hypothetical concept. Okay?
Sir,
Yes?
sir, so does that mean it does not exist in reality?
Yes, it does not exist in reality. But the thing is, see, we have to give logic to certain things that are taking place in reality. For example, let's take a very controversial topic. We have not seen God. Maybe you are Hindu, Muslim, Sikh, Isai, matlab Christianity, Buddhism, but we have not seen God by our own eyes. It's something which were, it's something that is told by our grandparents, and their parents have told them, and it's from centuries we are following the rituals, and maybe because of our faith we get the results, but in reality we have not seen the God who have created this entire thing. But now the earth is created, and in the complete solar system, in the complete Milky Way galaxy, we have not find any single planet that is very much resemble to our earth, or because the all the things that are required for life is perfect on earth. But some of the planets are slightly away from sun, some of are very close to sun, some of them are very cold, some of them do not have land, some of them have only gases. I mean, see, on earth it's a very critical probability. Out of millions of planets, only earth have life. So we say that God has created it. Then some of the group, I mean some group of scientists say no, it's not because of God, it's because of a probability. Everything comes on a certain time perfectly, and that's why our earth is formed. So what we are doing, we are giving hypothesis, we are giving some theories which are not practically proven, that is something which are working on, but in order to explain someone we need some answers. Are you getting this point? Similarly, resonance is also the similar thing. In order to answer the things that are taking place in chemistry, we observed, we actually put forward a hypothetical concept that is called as resonance. Is this clear with everyone? Is this clear? Any problem with it? Okay.
No, sir.
Now, guys, what happens is, when we learn about Lewis structure and we form Lewis structure by first finding T, then we find out V, then we find out S, then we find out U. We all have seen that, na, guys? We all have seen that in the previous lecture on on the last Thursday, right? So with the help of that examples, we will be able to form one Lewis structure. But you know, in reality, there are certain molecules that have more than one type of Lewis structures of it. For example, I will talk about ozone. I will draw that also for you. So ozone is a substance, ozone is a molecule that can show two different types of Lewis structure. So now, if we draw only one Lewis structure of a molecule, we will not be able to explain its entire property. So in order to explain the entire property or the complete property of a molecule, we have to draw its more than one Lewis structure. Is it clear? So let's get started. In some molecules, the structure cannot be represented by a single Lewis structure because their structure keeps on changing. Now, in order to get the accurate information, such as their energy, such as their position of nuclei, such as their bonding and their non-bonding electron, we need a series of representations. So in order to get all these properties of a molecule, we will not be able to find all the properties by single structure. So therefore what we do? We draw more than one structure. This is clear? So there are certain molecules in organic chemistry whose properties cannot be studied or cannot be represented by drawing one structure. Therefore we make more than one structures of it. We make more than one structures of it. And when we draw more than one structure of that molecule, that structures are called as resonance structure or the canonical structures. These are called as resonating structure, canonical structure or resonance structure. Now according to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, a number of structures with similar energy, similar position of nuclei, equal number of bonding and non-bonding electron are taken as the canonical structure of the hybrid which describes the molecule accurately. So now what we do is we draw all the possible structures of that molecule. We draw all the possible structure of that molecule, all the possible resonating structure, and then from those structure we take a hybrid structure, and that hybrid structure is now able to explain entire properties of the substance. Okay, so that is called as resonance. Now guys, let's see in reality. Let me tell you, in reality, when we have this ozone structure with us, guys, you all know that ozone structure, in that we have one single bond between oxygen and one double bond between oxygen and oxygen. Now as per the concept of bond length, when we take the X-ray image of ozone, you know, we were shocked. Why? Because according to the X-ray image of ozone, when the oxygen have a double bond, then it must have a bond length of 148 picometer. And when the oxygen carries double bond, then its bond length must be 121 picometer. So we were all sure that whenever oxygen have a double bond, its bond length should be 148 picometers, and oxygen double bond, its bond length should be 121 picometer. But guys, you tell me, who said that only these two oxygen carry double bond? You know, sometimes you can also make this structure like this. Now these two oxygen have double bond, so therefore its bond length must be 121 and its bond length must be 148 picometer. So similar here we saw that in structure number 2, This is structure number 1. Now in structure number 2, these two oxygen carries a single and these two oxygen carries a double bond. Now in structure number 1 and structure number 2, these two structures are called as canonical structures. These two structures are called as canonical structure number 1 and canonical structure number 2, or maybe resonating structure number 1 and resonating structure number 2. But guys, you know what? When I observe the real structure of ozone that is present in reality, all the oxygen atoms have equal bond length. All of them have equal bond length, which means not these two bonds are 148, nor these two bonds are 121, nor these two bonds are 121, nor these two bonds are 128. In reality, the bond length between all the oxygen atom is 128 picometers. So therefore, we will make this resonating hybrid of that resonating hybrid structure of 1 and 2. Now what happens is, we said in between oxygen 1 and 2, first there was double bond and now it's a double bond. So actually this double bond is moving, this double bond is rotating, which means at some time this oxygen 1 and 2 carries double bond and now this double bond switch their position and now you see a double bond here. So now sometimes for some seconds, for few microseconds, these two oxygen carry single bond, its bond length is 148 and now double bond jumps to this position and now these two carries a double bond, their bond length decreases to 121. Similarly, sometime you see a double bond here and sometime you see a single bond here. So sometime its bond length is 121, sometime its bond length is 148. That's why in reality these double bonds are moving, which means in reality neither oxygen 1 and 2 carries a single bond nor they carries a double bond. They carries a partial double bond, which means a bond which is something in between single and double. And also your oxygen atom number 1 and 3 carries neither a complete single bond nor a complete double bond. It's actually present in between 1 and 2. So that's why the bond length is 128. So this is how we justified this fact that if oxygen is present in ozone and there are 3 oxygen atoms, so why their bond length are 128 only? Because as per the Lewis structure, you are showing that one oxygen have single bond and one oxygen have double bond, which means as per the rules, as per the previous data we have, oxygen must have single bond, so its bond length will be 148, and double bond, its bond length must be 121. But why it is happening that in reality the actual ozone molecule that is present with us have a different bond length? Are you getting this point? No, Abdul, it should not be the average. That's the thing. See, that's the hypothetical case. We are not taking average. How we can take the average? Because this partial double bond is not exactly 1.5. If you take one bond, if you take double bond, 1 plus 2 divided by 2, it will become 1.5. So no, that's not the thing. It's somewhere in between single and double, which seems to be more closer to the double bond, which means this oxygen or these oxygen atoms have a partial double bond character. That's why their bond length are pretty much closer to the double bond only. They are not very much closer to the single bond. Are you getting this point? So this is the concept of resonance. This is what we call resonance. So resonance is actually a hypothetical concept and we use this concept to use this concept for those molecules that have more than one types of molecule representation, and in order to justify their property we will draw we will draw all the types of structure it have and then we take a average of it. Is this clear with everyone, guys? Is this clear with everyone? Let's take one more example. Let me teach you one more example of resonance. Okay, so guys, you must be knowing this fact that benzene that we have with us, that the benzene molecule that we have with us is having this type of structure. Guys, is this clear with everyone? This is the structure of benzene. Now you tell me, I have already taught you in today's lecture, whenever your carbon-carbon single bond is there, its bond length must be 154 picometers. So its bond length will be 154 picometer and its bond length will be also 154 picometer. And what about the double bond? Its bond length must be 133 picometers. This is also 133 picometers and this is also 133 picometers. But guys, this is only one type of structure of benzene we have. Can I say कि क्या ही फर्क पड़ेगा if this carbon and this carbon have a single bond and these two carbon have a double bond, then this carbon have a single bond, then this carbon have a double bond, then this carbon have a single bond, and then this carbon have a double bond. Will it make some difference? No. Still this is your benzene. So what you observe here, that sometimes your carbon 1 and 2 have a double bond, sometimes 1 and 2 have a single bond, 2 and 3 have a single bond, 2 and 3 have a double bond, 3 and 4 have a double bond, 3 and 4 have a single bond, 4 and 5 have a single bond, 4 and 5 have a double bond, 5 and 6 have a double bond, 5 and 6 have a single bond, 6 and 1 have a single bond, 6 and 1 have a double bond. So this is your resonating structure number 2 of benzene, where this is 133 picometer, this is also 133 picometer, and this is also 133 picometer. And when I talk about the single bond, so now this carbon 1 and 2 have a bond length of 154 picometer, 154 picometer, and this is also 154 picometer. Is this clear with everyone? First tell me. But you know what happens in reality? What happens in reality? In reality, when we see the real structure of benzene, this real structure of benzene have a partial double bond character with all its bonds. No two bond between carbon have a single bond and no two carbon have a double bond. They have a characters in between them. In reality, you will see that all the bonds that is present here, they all have 139 picometer bond length. They all have a bond length of 139 picometer. So that's the actual resonance hybrid structure. So that's the resonance hybrid structure. So how we justified this thing? That people when ask us that benzene have a bond length of 139 picometer. How is it possible? Because you are saying that 3 carbons have double and 3 carbons have single bond. So we will say that no. This structure is correct. The reality is truth, because the benzene have all the carbons of benzene have a partial double bond character, which is shorter than single and slightly bigger than double. So it's somewhere between in single and double bond. That's why the bond length is 139. And how we justified that? We said that sometime carbon show single bond, then this double bond shifts here and it shows single bond. Then these two showing double bond, then sometimes this double bond shifts here and now you see double bond here. Now this double bond is here, sometime it shifts there and you see a double bond here. And this double bond is keep on moving and moving and moving in the ring. So because of movement of this double bond, we will see that no carbon-carbon atom have a single bond and no carbon-carbon atom have a complete double bond. It's somewhere between single and double, and that is the concept of resonance. Is it clear with everyone, guys? Okay, that's great, superb. Now, in general, it may be stated that a resonance stabilizes the molecule as the energy of the resonance hybrid is less than the energy of any single canonical structure, and the resonance average the bond characteristics as a whole. Now you tell me, this bond have a high energy. Why? Because it only have 3 double bond and 3 single bond. This energy is also high because it have 3 double and 3 single bond. But this is very stable molecule. None have double, none have single. All have same bond length, therefore all have a stabilized energy. So this resonating structure, this hybrid structure of resonance is actually a very stable form of all the possible structures that are available. So if I talk about benzene, there are 2 possible structure. So we will not draw both the structure. We will draw their resonating hybrid. That's why, you know, in reality, we always make benzene like this. So now you know why we always make benzene like this. We draw a ring in between them. We draw a ring between benzene. Why we do so? Because we say that this double bond is present everywhere. This is a double bond is actually moving between carbon to carbon. That's why we draw circle in the benzene. Okay, so that is the concept of benzene. So now a question comes, resonance does stabilizes the molecule, true or false? बिल्कुल true है, it is 100% true, because resonance is actually given to stabilize the molecule. Okay, now can you draw all the possible structures of CO3 dinegative, guys? You want to give it a try? You can use that trick. First find T, then V, then S, then U, and with that draw the structure of CO3 dinegative. Come on, do it fast. So Abdul, yes. So with that, can you tell me how many possible structures are there for this particular carbonate ion? Very good, beta, superb. So guys, when you start drawing the structure of this carbonate, you will be observing one carbon having a double bond with this oxygen, then this is how you are forming the structure of carbonate, everyone. And in the square bracket, you are putting in -2 charge over here. Now tell me, if this is your oxygen atom number 1, this is your oxygen atom number 2, and this is your oxygen atom number 3, can I make one more structure where now this carbon have a single bond, this carbon have a double bond, and this carbon have a single bond? So now as then, I mean in this condition, your carbon 1 and 2 have a double bond. Well, carbon have a double bond with oxygen atom number 2. And one more thing, guys, you can do. I mean, one more thing, it's possible that carbon have a single bond here, carbon have a single bond here, but have a double bond with this oxygen between carbon and oxygen atom number 3. So can I say that overall there are 3 possible structures of CO3 dinegative? Yes, everyone. So now when you have to make its resonating hybrid structure, you will take arrows like this. You will write carbon in center, you will write oxygen, oxygen and oxygen here. You will make 3 single bond, and that you will make dot 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 dot. and you will make a 2 negative charge here, and that will be your most stable resonance hybrid. And this is the canonical structure number 3. That's canonical structure number 2, and that's canonical structure number 1. Okay? So is this clear with everyone? Arey wow, superb. So that's resonance for you. See, I have given answer also. Chalo. Guys, what will be the bond order of CO? Anyone? We have seen this in the previous lecture. I mean today only, but in the previous lecture. Very good. Superb. Superb, Abdul. Very good, guys. So its bond order will be 3. Its bond order will be 3. Superb. Very good. Shabash. Very nice answer, guys. Very impressed. Okay. So the oxygen-oxygen bond length in resonance hybrid of ozone molecule is 121, 148, 130 or 128? Guys, in resonance hybrid I am asking. It's 128. Somewhere between 148 and 121. That's 128 will be the right answer. Chaliye, so once this is done, we are complete. We have finished the concept of resonance, and now we are starting a very interesting topic that is called as polarity of the bond. Polarity of the bond. But guys, before moving further, I want you all to please tell me that do you remember the concept of electronegativity or not? Do you all remember the concept of electronegativity? Who wants to explain the concept of electronegativity to me? Who will explain the concept of electronegativity? What was electronegativity, guys? Come on, fatafat. The ability of an atom to attract the electron. Very good. Very good. Zabiullah, very good beta. Very good answer. Superb answer. Very good, Abdul. So basically, electronegativity means the capacity of an atom to attract the shared pair of electron towards itself. And can you tell me some of the most electronegative element? I mean, which one of, I mean, can you tell me the most electronegative element? Who is the most electronegative element? Fluorine. Very good. Chalo. So you all remember the concept of electronegativity. Now guys, see, we have two types of compound with us. First are ionic compounds, and the another one are covalent compounds. The another one are covalent compounds. Guys, I hope you all know that covalent compounds are those that have electron pair shared in between them. They have a shared pair of electron. And ionic compounds are those compounds that have completely donated their electron. So if I talk about ionic compound, I have Na which have completely donated its electron to chlorine, and that's why they have an ionic force in between them. Everyone clear? So now guys, see, when on one end we have a positive charge accumulated, and on the another end we have a negative charge accumulated, then in such case the bond will become polar bond. The bond will become polar bond. Is it clear with everyone? So if somebody asks you what is a polar bond, so a polar bond, which means that have two opposite poles, like on earth, north pole, south pole, they are two opposite poles. Similarly, on one side we have positive charge and on another side we have negative charge. So when these two opposite charge are present on a same molecule, are present in a same molecule where one side is positive, another side is negative, so the newly formed bond will be a polar bond. Is this clear with everyone? So please remember, all ionic compounds, all the ionic bonds are polar in nature. They all are polar in nature. Is it clear? But when I talk about covalent compound, they are having two types of bond. Number one are typical non-polar bonds and the another one is a typical polar bond. Now guys, this non-polar bond is formed when the atoms have same or nearly same, either they have same or nearly same electronegativities, and polar bond is formed when the atoms have different electronegativities. Is it clear? They have different electronegativities. Now see how. Let's say I have Cl2 molecule with me. Now if you have Cl2 molecule, then both the atom of chlorine, they have same electronegativity. So therefore this chlorine-chlorine bond is actually non-polar in nature. Are you getting this point, guys? Similarly, let's take one more example. All the carbon-hydrogen bonds that we have with us, here also all the bonds are non-polar. Why non-polar? Because the electronegativity of carbon and hydrogen is almost same. So therefore you will see that they are non-polar bond, which means there is no charge accumulation on one side. You will never see a positive charge accumulating on carbon and you will never see a negative charge accumulating on hydrogen, because they both do not have tendency to attract or release the electron. But when I talk about this compound, let's say I have H and F molecule with me. So guys, now you know that fluorine being more electronegative, you all know that fluorine is more electronegative and hydrogen is less electronegative. So now here what will happen? Here this fluorine will keep its electron obviously closer to itself, but this electron of hydrogen, this fluorine will try to attract that electron towards itself. So initially you will see that hydrogen atom is looking like this, fluorine atom is looking like this, and your molecule is looking like this. But when fluorine starts the electron of hydrogen towards itself, then it will look something like this. This will become like this. Fluorine's electron cloud will become greater, and therefore this fluorine will occupy a partial negative charge and hydrogen will occupy a partial positive charge. Guys, here observe, we have not written +1, we have not written -1. Here this delta positive means partial positive and this delta negative means partial negative. Guys, please remember, this is partial positive, it's not equal to +1, it's smaller than +1. whenever you see this partial positive charge here, it means that electron is not completely donated or accepted. Electrons are not completely donated or accepted. It's just like this fluorine has slightly attracted this electron towards itself. For example, how many of you, because of night hunger or food craving, you prepared Maggie with your brother or sister without knowing your parents? Your parents are sleeping and you silently go to the kitchen, maybe with your brother or sister, and you cook Maggie. But the problem is, yes, Zabullah has done it. But what happens is, you have only that one packet of Maggie with you. Now the problem is, you have to share that Maggie with your brother or sister. So you cook that Maggie. Yeah, you cook that Maggie, put that into one plate, and now you make a line in between that this part is mine and that part is yours. But as soon as your brother or sister is going back to the kitchen, or for example bringing some water or maybe a coke for you, you slightly slide some of his or her Maggie towards your side, or maybe you just take your fork, just put that in the side of your brother's Maggie and make a roll, and oh, gup, एक bite ले लिया from your brother's side. So you are not denying the fact that you don't want to give complete Maggie to your brother or half to your brother, but still you are slightly scratching a bit from your brother's side so that you have to eat more. For example, first you have separated that 50-50%, but now when your brother is gone to back to kitchen, maybe bringing something, you take some of his Maggie and eat. Now you have 60% Maggie and he have only 40%. So this means that still your brother is having Maggie to eat, but you have eaten a bit more. That is called as polarity. Are you getting this point? सर आपने किया है, अरे मेरा कोई ब्रदर सिस्टर ही नहीं है, आई एम द लोन, आई एम द सिंगल चाइल्ड ऑफ माई पेरेंट्स, सारी प्रॉपर्टी अपन की है, कोई चिंता की बात नहीं है अपने को. आई एम द होल सोल ओनर ऑफ द प्रॉपर्टी. Same only child, अरे वाह हिबा, that's great, you are also the whole soul property owner then. बहुत किया है तो you all got it now. So now, sir, 3 portions. Oh shit that. बहुत अच्छे अच्छे पॉइजन्स के बारे में मैं जानता हूं. प्रॉपर्टी पर चले गए आप तो. अरे प्रॉपर्टी पर जाओ या नहीं जाओ, प्रॉपर्टी पर तो आना ही पड़ेगा कभी ना कभी. राइट समीक्षा? आई मीन यू वांट इट और यू डोंट वांट इट, होना तो यही है, मिलना तो अपने को ही है. सो आई कीप ऑन फोकसिंग, मम्मी ये गोल्ड ले लो, मम्मी ये गोल्ड सस्ता है, पैसा ही पैसा होगा बाबू भैया. बस जोर जोर से बोल के किसी को स्कीम नहीं बतानी है. चलो. So now guys, do you understand that now because of this electronegative nature of fluorine, he attracted the electron of hydrogen towards itself. Therefore, you observe a partial negative charge on one side and partial positive charge on one side. So therefore, this bond is also now a polar bond. Guys, is this clear with everyone? So what are the types of polar bonds? What are the types of polar bond? Polar bonds are those bonds that have charge separation on the both side. At one side maybe a complete positive charge or maybe a partial positive charge, and on the another side complete negative charge or maybe partial negative charge. I don't like money, money likes me. Yes, that's great Samiksha, that's great. I don't like money, but I don't know why money likes me. Violence, violence, violence. I don't like violence, but violence likes me. Chalo. So is this polarity concept clear with everyone? So now a bond having 100% ionic or covalent nature is an ideal situation. But in reality, no bond or a compound is either covalent or ionic. Are you getting this point? So in fluorine molecule, there is a complete non-polar covalent bond as both the atoms exert equal force on the electron. That means because of same electronegativity, as the result electron pair is situated exactly in between them, which means F2 molecule, we consider that molecule as a non-polar molecule because the electronegativity of fluorine is same on both sides. But if in case of HF, we know that the molecule that is formed, the electrons will move more closer to fluorine due to high electronegativity in comparison to hydrogen. So we will get a polar covalent bond. The arrow which side is negative. See, I have formed this arrow, the arrow which looks like this. See, this is the sign of polarity. The head of the arrow should be towards the atom which is more electronegative, and this tail side should be towards the atom which is less electronegative. Okay, now let's move and let's see this example. As you all know that fluorine atom have same electronegativity, so they have the same electron cloud spreading everywhere. But this hydrogen and fluorine have a problem. The fluorine will attract the electron pair towards itself. That's why see, the hydrogen side is now quite shrunk. It's quite shrinked. It's shrinked a bit. It's not that much circular. Which see the electrons are not properly spreaded. Here it have partial positive and it have partial negative charge. So basically, the difference in the electronegativity makes the molecule polar and bring a force in one direction called as dipole moment. Now guys, see what is this dipole moment denoted by mu. Like see, you all know that if I make a bond with fluorine, I make a bond with chlorine, I make a bond with bromine, and I make a bond with iodine. Guys, you all know fluorine, chlorine, bromine, iodine are from group 17. All of them are negative, and because all of them are negative, all of them will have a polar covalent bond. Therefore, all of them will have a partial negative charge, and in every case this hydrogen have a partial positive charge. But guys, you tell me that in case of HF, this delta negative, and in case of HI, this delta I negative, both of them are same or different? I mean the value of delta negative in fluorine and the value of delta negative in iodine, is this same, or should I say is the bond polarity or the polarity of bond is equal in all the cases, or maybe they are different? All of them are equally polar, or maybe they are not, they are different in polarity, they possess some difference. What should be the answer? What should be the answer, guys? What you say? The polarity of hydrogen fluorine bond, is it equal with hydrogen chlorine, hydrogen bromine, hydrogen iodine, or maybe all of them have a different polarity? What do you say? Come on. Very good, Abdul. The correct answer is no. Why? Because as I already told you that hydrogen fluorine bond and hydrogen chlorine bond, their polarity is dependent on the electronegativity of the halogen atom. And you all know that fluorine is more electronegative than chlorine, then bromine, then iodine, which means the electronegativity of the halogens are different. And because their halogens electronegativity is different, therefore their polarity is also different. The hydrogen fluorine bond is more polar than hydrogen iodine bond, because iodine is very less electronegative. So iodine will not attract that electron of hydrogen towards itself, but the fluorine being more electronegative will attract the electron of hydrogen towards itself. So therefore the polarity of HF bond is higher as compared to HI bond. Is this clear with everyone? Is this point clear? So now the problem is, if the bond polarity is different, how we will be able to understand that? How we will be able to calculate that? How we will be able to know that which bond is more polar and which bond is less polar? So in order to find out, we use a concept that is called as dipole moment, denoted by mu. So dipole moment is nothing but the measure of polarity. It is nothing but the measure of polarity, which means if you get the high value of dipole moment, therefore your compound is very much polar in nature. And when your dipole moment mu value is small, which means the compound have a less polarity. Or when your value of dipole moment becomes equal to 0, which means your compound is completely non-polar in nature. Are you getting this point? So now dipole moment is denoted by product of the magnitude of the charge, that is denoted by Q, and the distance between the center of the positive and negative charge atom. So whenever you have to find out the value of, whenever you have to find out the value of mu, you can find out it by Q multiplied by R. So mu is equal to Q multiplied by R. So what is Q? You just find it out, Q from here. Maybe for fluorine, maybe it's minus 0.85, and for hydrogen it's plus 0.85. So you can write in place of Q 0.85 multiplied by R. Distance between the nucleus, its bond length, let's imagine it's 121. So you just multiply that and you will get the value. But for hydrogen and iodine, maybe its mu value is Q into R, but for its delta negative, maybe it's 0.35 only. It's plus 0.35, it's minus 0.35, and R maybe it's 150. So when you just multiply, you will get the value of HI. Is it clear, guys? Is it clear? And please remember, the unit of dipole moment is always denoted by capital D, that is dBi. Whereas please remember, 1 dBi is equal to 3.33564 into 10 to the power minus 30 coulombs meter. Why? Because see, this Q, that is your charge, its unit is coulomb, and this R, radius, its unit is meter or maybe centimeter. So coulomb multiplied by meter is equal to 3.33564 into 10 to the power minus 30 dBi. That is how you can find it out. So that's called as dipole moment. So is this dipole moment thing clear with everyone? It is the measure of polarity. The greater is the value of dipole moment, the greater will be the polarity of that compound. So let's write this thing here, which I am writing in, and you can download the notes afterward. If mu value is equal to 0, then you will say that your compound is non-polar. Your compound is non-polar. And when your mu is not equal to 0, then your compound is polar. And please remember, mu increases, your polarity of that compound also increases. Is this clear with everyone? Is this clear with everyone? Any doubts in it? You have any doubt in it, guys? Any doubt? If you have, you can ask. Or if in case you don't have any doubt, so why is dBi 3.3? Better, that's the mathematical conversion. See, whenever you multiply this coulomb and R, you will get some value. So this dBi was a scientist. So in order to get a simple value, we call it dBi. Like you know in physics, 1 Faraday is equal to 96500 coulombs. So they said that if 96500 coulombs, let's not use that. Let's use 1 Faraday in place of that. Like in Avogadro number 6.022 in 10 to the power 23 molecules, we call this at 1 mole. So that's simply like that. This total value is equal to 1 dBi. Okay. Okay. Now see, in case of polyatomic molecules, the dipole moment not only depends upon the individual dipole moment known as bond dipole, but it also depends upon their spatial arrangement, which means the arrangement of the molecules or the atoms in the molecule is also very important. So see, let's take an example of water. What is happening here? In water molecule, the two OH bond are oriented at the angle of 105 degree. So the net dipole moment is 1.85 dBi, is the resultant of the dipole moment of the two OH bond. See what is happening here. We have this oxygen atom here which is more electronegative. So the hydrogen and this hydrogen being partial positive, the electrons are getting attracted towards oxygen. Are you getting this point? Which means the net movement of electron is towards oxygen. The net movement of electron is actually towards the oxygen. So that's why we get this dipole moment. So that is a simple thing. This will happen. But observe here. When you have beryllium at the center, you have one fluorine here and one fluorine here. The bond angle is 180 degree, which means these two fluorines are completely away from each other. So now what is happening? One fluorine being delta negative is attracting the electron towards itself, and the another fluorine being similar electronegativity with equal force will attract the electron towards itself. So now you know what happens here. Because these dipoles are actually vector quantity, and when they moves equally but in opposite direction, and when you add their vector, it will ultimately becomes 0. So even though your beryllium difluoride seems to have two fluorine molecules in it, yet the net dipole moment is 0. You will call this molecule as a non-polar molecule. Why? Because these two dipoles are cancelling each other. So that is a very important thing. Even though they have a electronegative atom in it, yet they are cancelling each other. Okay? Everyone clear? Yes. Just see the previous slide. But guys, what is happening in oxygen? Both these dipoles are actually moving towards oxygen only. So they are actually contributing in such a way that one end becomes negative and one end becomes positive. So this side of molecule is positive and this side of molecule is negative. So that's the similar thing, that's the easy thing. But if you move in opposite direction, it will cancel out each other. Please check. Clear? Done? Okay, chalo. Now please note this if you want. Chalo, great. Now guys, there is a very important question guys for your school examinations. Please don't take this lightly. Everyone will ask this question. Let's compare the dipole moment of NH3 and NF3. Now guys, you tell me that fluorine is more electronegative. So you must be thinking that NF3 should have a more dipole moment and this NH3 should have a lesser dipole moment. Everybody must be thinking this, because obviously as compared to fluorine, this hydrogen have a very poor electronegativity. So therefore this molecule, because having 3 atoms of fluorine, must be very much polar. So its dipole moment should be very high, but this is not the case. Why? Just observe, when you see that this nitrogen have a structure like this, fluorine, fluorine and fluorine. Now guys, you all know that this lone pair of electron, so a electron cloud is here, one electron cloud is here, I mean the electrons are here, so you will see a negative charge here. Because of the presence of electron, you are observing a negative charge here. Now this fluorine, being more electronegative, will try to attract electron towards itself. But this fluorine, what it will do? It will try to attract the electron towards itself, and this fluorine will try to attract the electron towards itself. So now what is happening? One electron cloud is going here, one electron cloud is going here, one electron cloud is going here, and one electron cloud is going here. See, in NF3 molecule, the electron clouds are going away from each other in the opposite direction. But what if I talk about ammonia? Guys, ammonia have same structure, but the problem is nitrogen's electron cloud is here obviously, but nitrogen, being more electronegative than hydrogen, will attract electron towards itself only. So now you will see that all the electrons are actually moving towards one direction only, which means all these dipole will add up. So therefore you will see that the dipole moment of ammonia is greater as compared to the dipole moment of NF3. Even this nitrogen is more electronegative, sorry, fluorine is more electronegative than nitrogen. Are you getting this answer? So this is because in case of ammonia, the orbital dipole due to lone pair is in the same direction as the resultant dipole of nitrogen hydrogen bond, as I told you. But in NF3, the orbital dipole is in the direction opposite to the resultant dipole of the 3 NF bond. The electron dipole is going up, the electrons are present here, but 3 electrons are moving opposite. So therefore the orbital dipole, because of lone pair, decreases the effect of resultant nitrogen fluorine bond, and you will see a lesser dipole moment of NF3. Okay, you can see the diagram here. So the dipole moment of NF3 is 0.8 into 10 to the power minus 30 coulombs meter, and for NH3 it's 4.90 into 10 to the power minus 30 coulombs per meter. Okay, is it clear with everyone? Is this clear? What is white triangle in diagram? Abdul, this white triangle is nothing but it is the pictorial representation of the electron pair of this nitrogen. You know na that this nitrogen have 1, 2, 3, 4 and 5 bonds with electrons with it. So this electron is paired, this electron is paired, this electron is paired, but what about these 2 electrons? They are called as lone pair, na? We learned that in the previous lecture, that when these electrons are not participating in the bonding, they are called as lone pair. So they are denoted like this. They are denoted like this. So this is showing that the electrons are attracting electrons, or the orbital dipole is here because of presence of electron, and this electron is also going towards nitrogen, this is also going there, and this is also going there. So overall it is contributing in one direction. Okay, everyone clear? Yeah, this triangle, this triangle, this is nothing but the solid wedge bond. This is showing that this bond is coming outside the plane. Don't get confused. Don't get confused. This is just a confusing thing. Let's not get confused by this. This is just a representation of the bond that is coming outside the plane. So you can just make your bonds like this with hydrogen like this. Okay, now clear? Actually, that's a pictorial representation that your bond is coming outside the plane. We will learn that in organic chemistry. Maybe you have seen that in your class 10th also, when you were studying that carbon and its compounds chapter. There you have seen such three-dimensional bond, but if not, we will learn that in organic chemistry this year only. So not to worry about that. Okay, done? Is it done, everyone? So once polarity is done, let's see one question. So the product of the magnitude of the charge and the distance between the center of positive and negative charge is called as charge ratio or dipole moment. Okay. Only 3 students are active in the class, rest all of you are sleeping. Nobody is answering. You all got this or not? Are you finding my speed a bit faster, or maybe it's, yes, that's dipole moment. Okay, now I got it. Yes, now I can see some answers. That's good, very good. Dipole moment. Fluorine is more electronegative than boron. What will be the resultant dipole moment of BF3? Note it's a trigonal planar molecule. It's normal? Okay, great. So guys, what is saying trigonal planar with 120-degree bond angle, which means something like this. 120 degree, 120 degree, 120 degree. That's how your molecule will be like. So guys, what will happen if you keep boron at the center, fluorine and fluorine here, guys, what will be the dipole moment? What will happen with this? Will it be a polar molecule or a non-polar molecule? Tell me. Is it going to be a polar molecule or a non-polar molecule? What do you think, guys? Aban is saying polar. What about the other students? not getting this. गड़बड़ कर दी. Beta, it will be non-polar. Array, just check now. This fluorine will keep dipole here, but this fluorine will take electron in this direction, and this fluorine will take the electron in this direction, which means electron will go this will go here, and this will go here. See, everyone is moving in opposite direction. Everyone is moving in opposite direction because of bond angle of 120 degree. If you have a circle, you can cut that in 3 equal parts only, 120 degree each, which means one dipole is going here, one dipole is going there, and one dipole is going there, which means everyone is cancelling out. So the net dipole will be 0. The molecule will be non-polar. The molecule will be non-polar. Yes, Sridharan, you are right. So please write down this. Very important question. Chalo, mu is equal to Q into R. Here Q and R is what? So I think that's the easy question. I think everyone would be able to answer this. What should be the answer, guys? What is Q here? Q is very good, charge, and R is distance of the separation. Okay, guys, 1 dBi is equal to what? 1 dBi is equal to what? Very good. That is 3.33564 into 10 to the power minus 30 coulombs meter. Okay, guys, so chalo, we have only 15 minutes left, and the Fajans rule is quite a lengthy topic. So I will not start this topic today. So actually for Fajans rule, I basically require some time to explain this topic because that's a very interesting topic and it requires time. So we will be starting this topic from the next class with VSEPR theory. So for today, that is it. That's it from my side for today. And we have finished a major portion of this chapter. But still 60% of this chapter is still remaining. So we will be requiring at least 6 more lectures to end this chapter because VBT, MOT is itself will take one entire day. Like if we will be meeting next Thursday, we will be first completing VSEPR and Fajans rule and we will be starting VBT only. Then on next Thursday, we will be ending VBT and starting MOT, and next Thursday, we will be ending MOT and some of the another things. So therefore, we will actually require 3 more days for it. Okay? Chalo, so that's all for today. Acha guys, see one interesting thing. You don't need to attend Saturday's lecture because on Saturday, I will be ending a small portion of periodic classification of element with achievers C and D students. That is periodic trends in the chemical properties. Okay, so on Saturday I will be taking that class. So now those who are interested can join the class to just restudy that, or if you guys don't feel to restudy that topic, revise that topic, you are free, you cannot, you will just leave that session. So maybe just join that, be there for some time and leave. Okay, so it completely dependent on you. I'll be taking that portion on Saturday. So bye bye everyone, take care, good night, see you everyone, good night. Bye bye, take care, good night.